this. If you were legally absent on Friday and you didn't finish the lab, I'll just excuse you from that half day. So make sure it's a legal absence. Illegal, then it's a 0. I probably won't look at the absences until the midweek, so get them done before I have a chance to look at them. All right, so number 7. Presidential candidates.
What is this?
This is the homework from that one I just passed out.
Oh.
The first one, not mutually exclusive, they can have an overlap. Did I give you number 8? I did not. I gave you number 9. Randomly selecting a female worker, randomly selecting a worker with a college degree. These are not mutually exclusive because you say to yourself, you have a female worker with a college degree. So if you can say that to yourself, then they are not mutually exclusive. Remember, mutually exclusive, think of your Venn diagrams. Your Venn diagram says these two boxes like this are mutually exclusive. They have nothing in common. This one says, here's my female, here's my college degree, here's my female with a college degree. So they are not mutually exclusive. Event A, selecting a person who is a Republican, selecting a person who is a Democrat, they are mutually exclusive. You can't select one person and have them be both a Republican and a Democrat. They can only be registered under one party. They can vote whatever way they like, but they can only be registered under one party. Stop me if you have any questions. This is where it gets a little trickier. This is your Venn diagram working here. A math conference has an attendance of 4,950 people total. Of these, 2,100 are college professors and 2,575 are female. Of the college professors, 960 of them are female. That means if I drew a little Venn diagram, here's my college professors, here's my females, I have this many, 960 who are female college professors. So in my diagram, it kind of helps me out a little bit. So if I want to know the probability of selecting a random person, God bless you, that is a female or, and I write it like this, a female or a college professor, I add the probability of a female, I add the probability of a college professor, and I subtract out the ones that are in common, the ones that are both. Very good with that? Don't forget to subtract that out, because you're going to count them twice, and you don't want to count them twice. Number 15 was nice. It's a little confusing the way they word it, but can one carton have all of these things happen to it? Yes. So they're not mutually exclusive. So the probability that you produce a carton with a puncture is 5%, 0.05. The probability that it has a smashed corner is 8%, 0.08. The probability that it has both at the same time is 0.4%, 0.004. So if you're going to find the probability of getting an or, a smashed corner or a puncture, this is your and statement that you have to subtract out. You would have counted it twice. And with decimals is nice, because when you see the decimals, you know you can't subtract one from it, because you're not going to be doing that. You're going to be adding or multiplying or doing something to this. Stop me if you have any questions or if you can't remember doing this. Again, I like the die one because the die, you can visibly see it. Put your die 1, 2, 3, 4, 5, 6. Rolling a 5 or a number greater than 3. So here's your 5. Here's your number greater than 3. So where did they overlap? Right here. So that's the guy I have to count out. Or my simple answer is, well, I checked 3 numbers, 3 out of 6. The visual on this is much better. And everybody wake up. It's Monday. Let's go. The probability of rolling a number less than 4, which is 3, or an even number, which is 2, 4, and 6. So I notice I counted the 2 twice. Or I can just go like this. 1, 2, 3, 4, 5. I got 5 in total. Don't count the double check marks twice. Count it once. Rolling a 2 or an odd number? Well, a 2 is not odd, right? So these are mutually exclusive. So I add the probability of a 2, and I add the probability of an odd number. The only numbers I don't want is 4 and 6. I want everybody else. So I want 4 out of 6 numbers. Can everybody do this okay? Yes.
Why did you subtract the 1 6 from it again?
From this one? From A? Because if you count to 5, you have 1 out of 5. If you count a number greater than 3, you count 4, 5, 6, you counted the 5 again. So therefore we had to subtract out the overlap. But if you write out your dice, it also helps you see it. Or just count the 3 that you check. That's another way to do it. The probability of randomly, there is probably a chart with this one, right? There's a pie chart with this one. Now pie charts are mutually exclusive. One section has nothing to do with the next. That's why they're sectioned off. So they're mutually exclusive. So selecting someone who is under 5, I just look at the under 5. And then 6.6 or 0.006, whatever you want to say, 6.6% is perfectly fine. Randomly selecting someone who is over, 45 or over. So I look for the 45. Now that means 45 or older. He could be 45 to 64, 65 to 74, or 75 plus. All it said was over 45. So I have to add those 3 together. Randomly selecting someone who is not 65 or over. Take your 65 and your 75, add them together, and subtract them from 1. Easiest way to go. Randomly selecting someone who is between 20 and 34. Go to your 20 and add together with your 25 to 34. Everybody okay with this? These are mutually exclusive. I like these problems because they had, excuse me, they had you take them off of graphs. And I like the graphs because the graphs kind of show there's no overlap in them. Same with number 21. Number 21 was a Pareto chart. And the Pareto chart, those bars do not touch each other. They do not overlap. So these are all mutually exclusive. So these OR statements are nice. Randomly selecting a person from the sample who did not give all public schools an A. You can add up all the other ones if you like, or you can just subtract the A from the total and then build your probability. You can build your probability and subtract it from 1. You can do it that way as well. Everybody getting these answers? Anybody care today? Kind of looks like one of those days. Did you all plan on a snow day? Yeah. Oh.
Not snow day, 2 hours away.
I didn't think it was cold enough to stick on the ground, actually. Randomly selecting a person from the sample who gave public schools a grade better than a D. So remember, better than a D is the A, B, or C. You have to add those together. Who gave a D or an F, add those together. There's no overlap on these bars, so you're just adding a straight OR. Randomly selecting who gave an A or a B, add the A and the B together. Okay, use the complement case for this guy, the DF. Since you added up the ABC, subtract it from 1. The only other things that can happen is a D or an F. My favorite charts. How do we do with this? Okay. Probability of finding a student who is a male or a nursing student. So I look for my probability of being a male. There's my males. My males are 1198 out of my total. My nursing majors, 819 out of my total. But I noticed I counted this little group twice. These are my male nursing majors. That's my and statement. So I have to subtract that out of there. And I use the same grand total. The probability of selecting a female or not a nursing major. So a non-nursing major would come from here. So do the same thing. Total females, total non-nursing majors, and get the total non-nursing majors here, and then get this guy, the overlap, and take that out.
You tried to get us on that one. A and C, the same thing?
A and C was the same thing?
Yeah.
Oh, yes, it is.
I need to write C.
Who is not a female. Yeah. The knots, I don't really like when they use the knots. Because, like, not a nursing major, why didn't you just say a non-nursing major? You know, or all other majors or something. The knots always are confusing. But not a female is the same as the male. Absolutely. Are we good with this? The or statements, be careful of the or. You're looking for where they overlap. And this one too. The person who only wears contacts or glasses, only contacts or glasses or only glasses are mutually exclusive. They have nothing in common, no overlap there. So just add them together, add their totals, and that's it. A person is a male or wears both contacts and glasses. Male, here's my total males. Here's my both. And this is where they overlap, the 177. A person who is a female or wears neither. So kind of the same thing. Person who is a female, there's my female. Person who wears neither, there's my neither, and there's my overlap. Are we getting the overlap from this? I like these charts a lot better. I like the charts on the ors because you really can see the overlap. The probability that it is a male or does not wear glasses. Does not wear glasses. Does not wear glasses means they can only have contacts or neithers. They can't have both because both means they wear glasses. So you got to be careful on that one. You move that one down. God bless you. They can only wear a contact or neithers. They can't wear glasses. They can't do both. Because both means they wear glasses. So again, this time around, you have two overlaps in here. Does that make sense to you guys? Two overlaps. You got two categories to use. Good? Then I gave you one from the test part, right? Just number 4, right? Oh, number 6? Okay. All right, let's see if I can get a blank space here somewhere. Of these things today. The counting principle, we've been using the counting principle. Permutations says order matters. Combination says order does not matter. Factorials and distinguishable permutations. I know Algebra 2 does distinguishable permutations because they would say, what is the probability of, let's say a word out, like a word of idiot. Say the word idiot. How many different forms of this word can I make using the same 5 letters? But what happens is if I change the 2 I's, did you notice I changed the 2 I's? Because it's the same word. So those are distinguishable permutations. So those I know you did on Algebra 2. We had to remove those. Somewhere, you probably did these a little bit, but probably was a while back, so we don't remember it as well. I'm just going to read the board because it's driving me crazy. Okay. All right. They call this additional topics, but actually, this is really like the crux of the probability. A permutation is an ordered arrangement of objects. The number of different permutations that we say for of a distinct object is n factorial. There is a special case for 0 factorial. We don't really hit the 0 factorial here, but n factorial. Permutations also work like this. If I have, I have 20 people in here. I need to select 3 people to be a vice president, a president, and a secretary. Does it matter who is my vice president, who is my president, who is my secretary? Do you care, John, if you're president or vice president?
I'd rather be president.
You'd rather be president. So order matters. So when I'm doing that, if I have 5 people to choose from, it matters what order I set them up in. So here's my president, my vice president, my secretary. I have 5 people to choose for the first one. Then if I choose John, because he has to be president, I have 4 people left to choose from. We looked at a little bit of these, and I told you we set up permutations for those, because I said this was coming down the pipe here. Now we choose Kevin, because he wants to be vice president. Now we have 1 left to choose, and you multiply these guys. So I have 60 different ways that I could send a president, a vice president, a secretary to the main office to represent our room. We write this with the permutation, and we looked at these a week or 2 ago. We have 5 things to choose from. We want 3 of them. And that's how we do this. So we can lay out the lines just like you laid out your probabilities, or we can write it as a permutation. Now, if I wanted to send all 5 people down, because I want a president, a vice president, a secretary, a treasurer, and a financial person, other than my treasurer, then I could say 5, 4, 3, 2, 1, or this is the same as 5 factorial, because order matters for this guy. Order matters. I get 120 ways to do this. 120 ways to order my 5 people to go down there. That's a lot of ways. A lot. I was always bowled over by the number of permutations and combinations that actually exist. Because sometimes kids will try it in their heads. Well, it could go A, B, C, D, E. It could go A, B, C, E, D. You could be there for a very long time. Okay? So these are the things we're looking at. The objective of a 9x9 Sudoku puzzle is to fill the grids. Oh, I'll tell you where I'm at. I'm sorry. They don't really have a lot of these, but 168, right? 168. Okay. The objective of a 9x9 Sudoku puzzle is to fill the grid so that each row, each column, and each 3x3 grid contains the digits 1 through 9. How many different ways can the first row, your Sudoku puzzle looks like this. It's sectioned out 9. And then it's sectioned 9 this way, all the way down. so that they have like a 3x3 block. This is one block. This is another 3x3 block.
So I have no idea how to play that.
You don't know how to play Sudoku? It's my favorite game.
Really?
I live on this game.
I didn't know how to play it.
Oh my gosh, it's not stressful. It's a nice, easy way to de-stress.
Might have to have a class. Might have to have a
No,
class.
after a while you get the hang of it, but when you first start it gets stressful.
Okay, so I'm gonna get you guys some easy ones, and we're gonna do
We're gonna have to.
Sudoku. There's also Ken. That's another number one. That's a little harder. That one's a little harder. I do all of these. You know what it is too? When you do these puzzles, it makes your brain power better.
Yeah.
And what you should do is before you take a test, an SAT test or a college level test that you're going entrance test, do a puzzle first. That supposedly gets something rolling up in something going in your brains that start the motors going.
You're supposed to chew gum or something.
Or you're supposed to do a puzzle, do a word search, do anything that causes, there's something in your brain, I forget what is released, but there's something that does that. So how many different ways can the first row, so here's my first row. It has 9 positions. How many different ways can this be filled? So how many digits do you have? You have 10, 0, you don't have a 0. You have 9. We use well, you guys didn't know this. Oh yeah, here. 1 through 9. You don't use a 0. Well, you don't use a 0 on this. So you use 1 through 9. So I have 9 different positions here, 9 numbers to fill in. So technically, if I wanted to lay out 9 positions, I would say I'd have 9 ways to choose the first one, drop it 1, 8 ways, then 7, then 6, then 5, then 4, then 3, then 2, then 1. And I would multiply these guys, which is the same as 9 factorial. You have a lot of ways to set that first one up. But it's not as simple as that, because even though, what did they get? 362,880? But even though that you set this up, you would never take that many tries to do this, because that's not how Sudoku works. Well, because they give you some numbers in there already, like they'll give you some numbers here, and then the next 3 you'll see another set of numbers, and you have to line them up. I'll bring in a Sudoku puzzle. We'll play Sudoku.
Only some people know how to play. It's a rare game nowadays.
It's a different game.
They become a new hobby. I do need a new hobby, so this could be
You
it.
need a new hobby?
Yeah.
This could be it?
Yeah, this could be it.
Oh. Okay. So as a matter of fact, they give you a Sudoku puzzle there, right? But I don't have how much. Okay. So that wouldn't work out. All right. So tomorrow I'll bring you in a Sudoku puzzle. We'll do a Sudoku. Yeah. All right. So that works out that way. All right. The women's hockey team that qualified for the 2014 Olympics are Canada, Finland, Germany, Japan, Russia, Sweden, Switzerland, and the United States. How many different final standings are possible? So how many teams do we have?
Yeah.
8 or 9? 8. So we have 8 teams. So we have 8 standings. Whenever you are at a loss, draw the lines. You have 8 positions to fill. How many teams can I select for the first one? 8. Then what? 7.
So it's just 8 facts.
So it's the same as 8 factorial. How would I write this as a permutation? 8 things taken 8 at a time. 8 things taken 8 at a time means start at 8, go all the way down 8 positions. I'm sorry. You're making me lose my voice. So when you're doing this, sometimes they will say, well, how many people actually win the medals? There's a gold, a silver, and a bronze. Only 3 people can win. So sometimes you do this. Gold, silver, bronze. How many teams can qualify for a gold? 8. Then how many? 7. Then 6. because I can only really place 3: gold, silver, and bronze. That's my 8 things, taking 3 at a time. I can only take 3. So if I can only take 3, I lay out 3 lines. That's how permutations are going to work. Lay out the lines. In your calculators, if you're looking for the permutation, again, if you go to math, if you come all the way over here, there's where your probabilities are. Here's your NPR, CNR, and NCR, and factorial. Now, the only problem with this is, if I'm going to enter this, even in factorial, I need to say my number first, 8, and then I need to go to math. Then I need to come down here and use my factorial button. If I set up my permutation, I need to set the first one on the left up, 8, then go to math, then come here, and then set this guy up, and then I can put my 8. And you'll get the same answer. 8 things, 8 at a time, 8 factorial. Okay? This is just to get us started in this. Alright, so probably this is good for today.